Welcome to this webinar. Today it's all about milk receiving, eliminate drug scales using Coriolis mass flow. This is the third webinar out of 4 global food webinars that we are organizing. It's always every Tuesday at the same time. Before we start with the webinar actually itself, I would like to show you how the webinar panel works, how you can use the software. So you should see us via our webcams. Of course, you can play with the sizes of the presentations according to your needs. Important for you to know is you can download the presentation file in the download section. Also, what you can do during the webinar, you can ask questions. I try my best to answer as many questions as possible. If we cannot answer them during the webinar, we will follow up after the webinar. Also, what you should know is that this session is recorded and we will put the recording of the session on our webpage, endress.com. More information at the end of the webinar. Before we start, I would also like to introduce ourselves. My name is Jürgen Ganzmann. I'm the Global Industry Manager for the food and beverage industry at Endress Hauser. And today's presenter is Wesstrom, my colleague from the US. He's our Senior Industry Manager for food and beverage in our sales center in Endress Hauser, USA. Ola, stage is yours. Thank you very much.
All right, thank you, Jürgen. So welcome to the session here. So we're looking a little bit specifically related to milk receiving. But before I even get into that, I just want to make sure everybody have a clear understanding that we picked milk receiving as a baseline because it's really one of the toughest applications to meter incoming products to a plant. For sure, you have other incoming products to a food processing facility. It could be oils, it could be liquid sugar, molasses, or other type of products that are arriving either via rail car or by truck coming into the plant facilities. And I'll share in a second here why we picked milk as the most challenging example. But that's kind of the fundamental for it here. And clearly, metering can be used not only for receiving applications, but also for outgoing, so outloading of product as you send it over to your customers or to other food processing facilities. So we'll go through looking at the milk intake, the application itself. We'll go a little bit deeper into what the challenges are. And then depending on which country you're dialing in from, there's going to be some differences on how the legal for trade aspect is. I will share how it is handled in the United States. You might see some similarities or there might be differences to your local regions or countries. And we'll go through that and then kind of generally see how a Coriolis mass flow meter ultimately can help you eliminate the truck scale or other ways of custody transfer or supporting plant mass balance as well. So if we look at a basic layout of a receiving type of area, this particular here is looking at milk intake. So you have a truck. Now this could also be a rail car if it's other products, but generally we're looking at trucks coming in here. A couple of very important components that you need to have is an air eliminator. And the reason we picked milk, the challenge here is that the milk inherently have a lot of air bubbles in it, micro bubbles. It's a little bit to do to when you're pumping the milk, but it's also as the trucks are driving on the roads, the milk is sloshing around inside the tankers. It just generates a lot of entrained air bubbles, really small micro bubbles. The air eliminator here is not going to be able to remove those micro bubbles, but for a meter-based system to work, we need to make sure that we get rid of any air slugs that is inherently going to be present when you're hooking your hoses up to the system. So you're going to have a hose coming out of here and going into your system, and if that's, you know, as you're starting, there will be some air slugs in there, and that's the primary purpose for the air eliminator, is to get rid of those air slugs. And then as we go through the installation here, usually we will have some kind of filter to eliminate anything that unwanted coming in. And our main focus will be on this flow meter here. Traditionally, or many cases, this is a magnetic flow meter that is being used here. So you're measuring the volume coming into the plant. And they work well. There's no issue with that. The challenge you have with using a volume-based measurement here is that because of the micro bubbles that you have in the milk, which can be up to 10% air bubbles, your volume is not really going to be representative of the amount of milk that you're bringing in. So as a result, as the milk is settling in the storage tank, the air bubbles, the micro bubbles are migrating out from the milk, and you get the perception that you received in more milk than what you actually have on hand. So there is then an accounting error that occurs, which could be very difficult then if you're using this information for plant mass balance or planning of your production. Because let's say you have 3 to 5 to 10% of entrained air, well, that's what's going to be your potential error in the plant mass balance calculation. So that's what we're looking at, changing this over to a Coriolis mass flow meter. Before we get into the technology itself, it's like why would we want to do a meter-based technology rather compared to other ways of measuring or keeping track of billing and or inventory? One of the biggest challenges we've seen is the traffic. So you have a large number of trucks entering and exiting the facilities. Larger dairies, it could be 50 to 100 or even more trucks per day getting in and out of the facility. And as a result from that, we potentially get traffic jams or just a backup of trucks sitting and waiting to get access maybe to the truck scales to get weighed in and to weighed out again. Meter-based as well is now you have an actual mass measurement, so you know how many kilograms or pounds of milk or product that's coming in. You also get the volume, because with the Coriolis mass flow meter, you have both variables. You have mass flow and you have a calculated volume. We can also look at the milk fat. Now, there's some caveat to this. Because of the untrained air, and we're using density as a factor to calculate or to measure this milk fat, this is not going to be super accurate as you're using this, but it's a very good indication if you're looking at potentially if you have adulterated product, or you're wondering, it's like, okay, has this truck been sitting too long? You see more, let's say, the lower density, lower milk fat coming in first, as the milk fat have floated to the surface. So you get more of a cream coming at the end of the load here. So you can use this to keep a track of, like, okay, approximately how much milk fat that is coming in and what's being offloaded from the truck. And you also get a secondary temperature reading that can then be used for the load ticket or the receiving documentation. So the meter itself don't only gives you the mass of how much product you're coming in, but all the other variables as well. In some countries, they're still using the dipstick method, which is essentially at the dairy farm. They use a metered metal stake that they use to put into the tanks, and then they use that for metering. This we have seen from proven application is very inaccurate. You can easily have up to 10% error if you're using the dipstick method as a means to understand how much you're coming in. Most, let's say in Europe and United States and so on, this method is no longer used, but I know in many countries it's still in place. And if you use this, it's going to be almost impossible to keep track of what your plant mass balance is, because you really have no good visibility to how much you're actually receiving into your plant if you're basing the accounting on that method. Then you have some capital expenses as well. So let's say you need to install a new truck scale. A new scale is about $200,000, could be more, to install. That's assuming you already have the land and everything available for it. And then it can be fairly maintenance intensive as well. So you can have up to $5,000 a year for just annual maintenance, cleaning, recalibrations, and so on of a truck scale. And when we start looking at the meter-based systems, we have on one hand, we have the custody transfer, which is where you're actually using the meter for billing purposes. So the custody point. So that then puts a much higher, let's say, requirement. You add a couple of additional components to it in order to be able to use it for custody transfer. And we'll go through what that means and what's included in that. More commonly, though, is just to use the meter as an intake meter, and then it's mainly for a check meter against what the truck scales are, or using it for your internal plant mass balance. To my point earlier on, comparing it to magnetic flow meters, knowing exactly how many pounds of milk or how many kilograms of milk that you have received in during that day or during those few hours that you might be receiving in. And the accuracy requirement for either one, the expectations as a system is usually to be about 0.2% accuracy. So that gives about 100 pounds on a 50,000 pound load. You can see it. We're looking at really tight accuracies here. If you have looked at specifications for magnetic flow meters, in addition to the error you get from the untrained air, a magnetic flow meter, just the meter itself, usually start at an accuracy of about maybe 0.2% or usually about 0.5% accuracy on the magnetic flow meter, while a Coriolis mass flow meter usually start at the 0.1% accuracy as a meter accuracy itself. So you're immediately stepping up your game as far as getting a better handle of what your plant mass balance and shrinkage of the facility is. So a couple of points here. I mentioned already the untrained micro bubbles that you get in the product or in the milk, is that's the case here. That this is really the main reason why Coriolis meters have not successfully been used up until now. Ourselves within Endress Hauser, as well as many other Coriolis manufacturers, have attempted to do milk receiving with very limited results. It's an honest statement there that it's very, very challenging to use a Coriolis mass flow meter for milk receiving. And the primary issue of that is all the micro bubbles, the untrained air bubbles that you get in the milk, which is essentially causing the meters to either stall or to get really low accuracy readings. There's been ways or attempted ways to compensate for this using electronics and data processing and so on. Maybe it works one day, next day if there's too much air, we really not sure. So to get the consistency have been very difficult. Fortunately though, from Endress Hauser's side, with the introduction of a ProMass Q, Coriolis mass flow meter a little bit over a year ago, I took a completely different approach. And I'm not going to go into the technical details here right now, but we took a mechanical approach to it and using multi-frequency oscillation of the tubes, and in that way accounting for and compensating for all those air bubbles in the inside the tubes that usually would cause it to fail. I mentioned earlier here, even an air eliminator here, people have this perception, oh, I use an air eliminator, I get rid of my air bubbles. No, you do not get rid of enough air bubbles for this here. You get rid of the air slugs, the big amounts coming through here. That's what the air eliminator primarily did here. It's still very important to have this on road because the better conditions you have, get rid of those slugs is very important in order for any flow meter to work, be it magnetic flow meter or anything like that. You need to get rid of those air slugs. So talked about that point already. Another aspect that we see errors, or let's say maybe people are not entirely paying attention to, is the selection and sizing of the pump. Because you have a balance here. Usually you want to get as many trucks as possible, offloaded as quick as you possibly can to increase your throughput of your plant here. So looking at that, people select the pump and try to, instead of pump the product into the plant, you're actually sucking the product out of the trailer or the truck. That's okay if you're not trying to measure it here. But if you're trying to measure it, you do need to pay attention to the net positive suction head. And what that is essentially the height that you're going to get, and before you really start funneling inside of a truck. You can imagine you have a tank. When the tank is full, you're drawing the product out. As the level is dropping inside of this tank, at some point in time, if you're drawing too much or pumping too much, you're going to start getting a funnel effect out of it. And if you get that funnel effect, guess what? You're drawing more air into the line, which will be a challenge for the air eliminator to handle, and therefore you might start affecting the accuracy and the performance of a flow meter based system. So if you're looking at doing a change from a magnetic flow meter to a Coriolis based, well, either way, actually, you should pay attention to having the correct pump applied. Another thing to look at, if you are making changes, if you do add a variable speed drive or variable frequency drive, which can then allow you to slow down the pump when you know you're starting to get towards the end of a tank. Let's say you're offloading, you have a tanker truck that should have 50,000 pounds on it. Maybe when you come to your offloaded 45,000 pounds, then say, okay, now let's start slowing down the pump a little bit. Then you're minimizing that funneling effect, and you're minimizing the amount of air that you're pulling into the meter. Here's another thing to keep an eye on. This may or may not be that common, but we see it ever so often, especially in larger facilities where you have either two separate compartments on a truck, or it could be a truck and a trailer. So you have a tow behind trailer. Many times on scales, you have to disconnect the trailer before you actually bring it in, because you can only weigh one thing at a time on the truck scales. Well, with a meter-based system, potentially you can have both tanks hooked up on the same time, go through the same meter here and meter it on the same time. What you need to keep in mind here, though, it's unlikely that both tanks are going to draw down exactly at the same level. You might have one emptying out a little bit faster than the other one. This situation is easily addressed simply by having a little empty pipe detector in the line in between, and then have an automatic valve. So as soon as this line is empty, you shut the valve, and therefore you're not sucking air into the meter. And while I'm talking about this here, you can see the two little graphs on the right-hand side here. Another function of the Coriolis meter is that we can actually look at when you start getting air into the system here. All right. So there's diagnostic capabilities in the meter to say, okay, we're measuring just fine. We have minimum amount of air in the meter. And if you have something like this happen, when for some reason you get air in the line, you can alarm on that and say, okay, for some reason we're getting too much air. We really cannot trust this measurement anymore. One example that we saw as we started installing these ones here were the truck drivers or the loading bay operators were not always paying attention and not always having the gaskets in place. So when they hooked up the hoses up to the truck, if they forgot to put the gasket in, guess what? You start sucking air in at that point. So two problems with that. One is obviously you're sucking air into the plant, and two, you're sucking air in. That's a potential contamination point. So to be able to monitor if we're starting to see more air than we expect to see, and then alarm on that, could then give the operators a heads up and say, okay, there's something not right here. You better have a look at it before you continue emptying out this truck. So here's the magic. Here's the Coriolis meter that makes all this possible. This is the Proline, the Proline Q. And again, anytime you see this little arrow, you'll have that in your in the handout. Let's say the PDF file. If you download that, you can just click on that link. It'll take you to the landing page for this product or any other links we have in here. This is also where there is the video is embedded, so you can see the technology behind this Q sensor that really makes all this possible to measure in applications with high volumes of untrained air. Couple of minor points here. Sizes up to 4 inches. This gives you, let's say, a 3-inch meter. You can probably run about 1,000 pounds a minute or something like that. So 4-inch meter, even more. There's no restrictions on the sizes here as far as how quickly you can empty out a trailer. And like standard mass flow is 0.1%, generally more than enough. If for some reason you want to have it even higher accuracy, you can go to the 0.05 option for it. But in my opinion, the 0.1% is going to be good enough for most receiving applications. Other things to look at, clearly frequency, pulse output, 4 to 20 Hz, those are kind of standard. Really leveraging the digital communication here, the Ethernet IP and the Profinet directly built into the meter allows you then to use our heartbeat technology, which is the built-in diagnostic and verification capabilities that allow you to daily, if you wanted to, go in and run a verification report that builds a trust for operators, say, yep, that meter is working exactly the way it should be doing, or it gives you early warning if there's something that you need to have a look at. So here's a little bit more about this heartbeat technology. The onboard diagnostic is just running non-stop in the background. This would involve, for example, looking at the untrained air error codes or anything else that might be drifting or giving us some reason to be concerned that there's something going on either in the meter or potentially in the process. So it looks at very, very deep diagnostic capability. And then you have this verification capability that you can run either by hooking up the wireless device to the meter and running it on an iPad or a tablet, or you can have it hooked up through the Ethernet IP or the Profinet and do a remote verification. So you can do that from your maintenance shop, or the quality department can run a verification on a daily basis, gets a PDF file and say, yep, this meter has passed all the performance criteria required. So that's a little bit about that heartbeat technology that's behind that. And then you can do that without interrupting the process. So you can actually run this verification while you're offloading a truck. It will not stop the measurement while you're doing that. All right, so I know you're all looking, it's like, okay, I'm still not really sure about this. You know, why would I go towards a meter-based system? What kind of performance can I expect out of this? Since last summer or so, we've started installing a number of his Promise Q meters at dairy operations throughout the U.S. and throughout the world. And here's just one example from one plant. So this was a little bit over 1,000 truckloads. So it was over roughly a 2-week period at this particular facility, where we were taking readings, comparing the meter readings, comparing it to the truck scale. So we have the truck scale here, and then we have the Promise Q. And this is just a few of the 1,000 measurements. We can see here the average. So we have the average. We were about 44 pounds error as an average, and that's what, 22 kilogram error out of a 25,000 kilo load of thereabouts. So the deviation was 0.086%. Now you might also, for those of you guys who are sharp-eyed here, you might say, well, there were a couple of them were kind of outliers. You know, it's like we were like right on the money most of the time here. But then there was a couple of times it's like, this is, why is it like this? Well, that's where we use that diagnostics. I mean, went in and say, okay, what is going on here? Why do we have a deviation here? And that's where we found these gasket issues that the operators, it wasn't really hooked up the right way. We were seeing others. So we could use this information to then do continuous improvements. Say, okay, how do we eliminate these kind of, or eliminate or minimize these kind of manual errors, which otherwise would cause errors. Okay, so overall the accuracy is excellent, and we can use the diagnostic to continuously improve on it as well. All right, so here was something we suspected, but we didn't really know how big of an issue it was. This was installed up in the upper Midwest. So we had a snowstorm, which is not all that uncommon. You know, in many areas you have snow and other issues going on. So they had a snowstorm coming in here, and we were continuously monitoring the scale, and then we had our meter, and then we could see the errors. And we had, you know, like 300, 100, you know, the biggest error was about close to 900 pounds of error showing here. Essentially that the scale was over-reporting by several hundred pounds because the snow, the weight of the snow on the truck was on the truck itself as it's being weighed in, and it goes in and it gets offloaded and goes back out again and gets its check weight on its way out to see how many pounds you actually offloaded there. In the meantime, a lot of the snow had melted off and it was no longer on the truck. So guess what? We had an average of 337 pounds of over-reporting when we're using the scale compared to using the receiving meter here, the Coriolis meter for that. So that was, for 50 loads in a day, that was 17,000 pounds of milk that was supposed to be in the plant, but that wasn't there. So how do you plan for that? How's your plant mass balance going to account for shrinkage, which essentially was snow on the scales? Snow on the scale has other issues as well. Many times in winters, the scales freeze over, they don't work right, and so on. So there's other issues using scales as well. But this here was just an example. It's like how much impact potentially snow and ice can have on scale readings. So now we get into the legal side of things. And again, this may or may not be applicable depending on which country you're in. But if you are looking at using it for custody application, essentially that is a billing meter. In the United States, it meets with the Handbook 44 for NIST for Coriolis mass flow meters, which then have the certain specifications and requirements that need to be fulfilled in order to use it as a taxation, sorry, as a billing meter here. So that might be something you need to look at your local countries, your local areas, and say what the requirements are there. But as a meter itself, it would meet with generally the requirements that you're going to come across. So when we go and look at it as a billing meter, there are a couple of other components that we need to look at as well. And you can use this for internal purposes. You know, if you just want to use it as a ticket printer to have physically a ticket to provide to the truck driver, that he has a document to say, okay, this is how much I delivered. You can use it for that purpose, or you can use it for the official billing purposes as well. But essentially here you have the Coriolis meter, the ProMass Q. Then you will have some form of a batch controller. So essentially it tells you it's essentially a fancy totalizer that can be sealed and secured so that nobody can tamper with the values in here. and then that goes into some form of a ticket printer. Usually it's connected into a basic desktop computer, and that's from there you actually print the ticket that the truck driver does. And it also then goes into your accounting system, so you can keep continuous track of exactly how much milk or product that you're offloading is going into your facility there. And the main differences here are the meter need to have a capability to be sealed. So you need to be able to put a regulatory seal, a weights and measures seal on the meter, and the same thing on the batch controller here. Essentially there to make sure that after the weights and measures inspector has signed off on it, that nobody can go in and tamper with it and change settings and so on, to make sure that it's secure and people can trust the measurements. So once you have that installed, you obviously want to make sure that it's working the right way. And this, you probably want to do this if you're using it as a custody meter, or if you're using it just for internal purposes as well. You want to make sure that it's functioning the way that you want it to do. And it's a fairly straightforward, easy way to verify the meter, and the term used, placing it in service. We're not just looking at the meter itself. It's going to be assumed that the meter has been calibrated, the meter is functioning. So essentially what we're looking at here, we're looking at make sure that the entire system is providing the accuracy and values that we're expecting, which then includes the pump, includes the air eliminator, anything else in between, let's say essentially from the truck up to the meter that we're checking here. The procedure that we usually follow here is that you have a truck coming in filled with milk. They go through the scale and gets weighed, and then they go to the loading bay, hooks it up, and they run it through the meter, and we empty it to about 1/3, and then we go back again and check weigh it and say, okay, is the meter matching with what the scale is doing? Yes, then we're okay. And then we do that 3 times. So essentially you split the load in 3, and you go through and just do it in 3 times. 1 check, 1 check, 1 check, everything good, then we're okay there. So as long as you stay within that 0.2% accuracy, and you're doing it repeatedly, 3 times over, it's got to be repeatable. You can't have one, where you're 0.2%, and then the next one is 0.3%, and then the next one is 0.2, and you do another one, 0.2. They have to be repeatable, consecutive, make sure that it's every time you have a truck come through there, it's going to do the same thing. But generally, that's what you do. Do it 3 times there, and then you say, okay, now we're good. We can put this in operation. So placing it in service is a fairly straightforward procedure. It takes some time, but nothing more than it would take to, let's say, calibrate a truck scale. Now, in addition to the flow meter itself, the Coriolis mass flow, there are potentially other applications that you might want to consider. Some of them are always used, some of them are optional. Many times we see on the incoming milk here, we see conductivity measurement. That could be either used to, generally used to see, do we have product or milk in the line, or maybe some rinse water still in there, so more of like a phase separation type of measurement. We also see pH measurement, and here we have, it needs to be this non-glass pH sensor, because you really don't want to have any glass sensor in here that could potentially break and get into the product. But a pH sensor, the reason for that is you could then, before you get potentially spoiled milk coming into the plant, you can block it. You can stop the process. If this pH value is too low, that means your milk has gone sour, and you do not want it to go further into your process, potentially get in and contaminate, let's say, the larger storage capacity you have in your large milk silos here. So an inline pH measurement is just a safeguard to make sure that there's no bad product coming into your plant. And then you have a couple of point level switches, pressure sensors, temperature measurement, and then hydrostatic level measurement, or free space radar that you would use on the raw milk tanks here. Traditionally, hydrostatic level measurement is used for the as a level measurement for tank level on the storage silos. We see more and more a trend going towards a non-contact free space radar measurement on the raw milk silos as well. So that kind of completes the picture for all the measurements that you will have in and around the milk receiving area, or let's say the raw milk handling. And I've talked quite a bit about the capability of a ProMass Q. These are other things that you'll see when you get to the, if you click the link and go to the website. This multi-frequency technology that we're applying on the ProMass Q allows us to do things that previously was just unheard of in using Coriolis mass flow meters. And we're talking about products that on purpose have air included in it. So for example, ice cream overrun, chocolate mousse, cream cheese, or other products that have incorporated air or potentially nitrogen or other things that are incorporated in the air to create a certain consistency. Traditionally, Coriolis meters like, nope, I don't want to do that. You know, it just didn't work very well. With the ProMass Q, it just works fantastic in there, and we're getting to a point that, like say for the ice cream overrun measurement, using 2 pressure transmitters as well, we're actually be able to tell you as a quality parameter how much entrained air, how much overrun you actually have in that product. And then we get into other products like viscous products that can have air bubbles and so on in there, which traditionally was very difficult to measure as well. So the ProMass Q really, you know, we're talking about, or I'm talking about right now on the milk receiving, because it is very challenging and it has a lot of entrained air, but this technology lends itself to a lot of other areas of applications as well. So to wrap up, we made a claim that when we posted his here that the return on investment for a milk receiving system can be as little as 3 months. And clearly there's a lot of variability in that. You know, it depends on, you know, what you have today, what you're doing, and so on. So to help you look at this a little bit, it's like, okay, where are those potential savings coming from? One of the first things that come up is, okay, we want to move as many trucks through this plant as we possibly can. All right, it just takes too long time to get trucks in and out of here to offload. Well, what if you could eliminate the stop at the scale? So let's say you reduce your turnaround time by 10 minutes. It's probably a low value, but let's say at a minimum you're going to be able to reduce the turn time by 10 minutes just by not stopping at the scales. So let's say the example I have here, you have 100 trucks a day coming in. That's 16 hours per day that you're saving in just, you know, downtime of trucks sitting, waiting potentially to get on the scale, or time that they're spending on the scale. So then you look at that. Can we reduce the operatings on the loading day or receiving day? Can we optimize that a little bit? You know, can we have fewer people working there? You know, they may not have to be a double shift. Maybe we can squeeze everything into one shift. Then I already talked about the accuracy. So now you're looking at, okay, plant mass balance. What are the implications if I don't know exactly how much product I have coming into the plant? What if I'm off by 5% or even 2 or 1% milk as for my accounting purposes or planning purposes throughout the plant? If I don't really know what's coming in, how do I really plan my operation and throughput of the facility? Mentioned also for countries where the sticking method is still used, we know that has easily 5 to 8% error. What if you can eliminate that and really know what's coming in? Then we have the truck scale maintenance, cleaning and upkeep. If you have one cell, usually there are 4 load cells on each truck scale. If you need to replace one, conservatively, you know, $7,000 to $9,000 just to replace one load cell there, and they do go bad on occasion, right? So have that. And then you also have a truck scale calibration. Truck scale calibration roughly runs about $2,500 a year. Let's say you need to recalibrate or check the meter itself. That's usually, you know, $750 to $1,000 to do the calibration of the meter itself. So you cut your calibration cost by half of it potentially. And depending on where you are, available additional land. Usually a truck scale takes quite a bit of space, usually about 1 acre or so that you need to set aside for a truck scale. Many places, if you're trying to expand or maybe you're in a landlocked area, that might be prime real estate for you. So there's another thing there. So there's not just one way of looking at the return of investment, you know, going towards a meter-based system. These are just a couple of things that have been brought to our attention as we've been working with different dairy operations where we say, okay, this is how this can benefit us. So with that, I'm going to wrap up. Jürgen is going to come back on again here, and we'll open up for questions.
Yeah, Ola, thank you very much. It seemed to be very clear because there are no more questions, but perhaps there are still some coming. In between, I just want to inform all the participants that, of course, you find all this information in the handout. As Ola already mentioned, you will find links in there. Just click on the links and you will be guided to the product videos and the products themselves. So that's all on endress.com. Also, again, to repeat that, you can follow us there in the events section. You just follow seminars, roadshows, and webinars, and there you will see all of our webinars that we had in the past. You can watch the recordings, but also you will see which seminars or webinars we are planning to have in the future, and you can register for this. Just to let you know, there's one more webinar to come in the next week for the food industry. There are more to come, of course, in the future, but one more planned one, a global one for the food industry. Next week, Tuesday, May 12th. Same time, it's about bulk solid ingredient level and inventory measurements, best practices for the food and beverage industry. Good, now we get some questions. Ola, how do you estimate continuous milk fat percentage on Promax Q?
Okay, so I touched on that a little bit. So because the Coriolis meter is measuring the, let's say, the concentration measurement is using a density function. So it's looking at the density of the product. So for example, in milk standardization systems or other areas, there we can measure the milk fat very accurately in those applications, because there's no, you only have the carrier fluid and then the milk fat. So you're only looking at those two variables. When you have milk coming into the plant, let's say from the trucks coming in, you have your milk fat, you have the carrier fluid, essentially the milk itself, and then you also have the entrained air bubbles. And the challenge is here is like, how do you tell the difference between three variables and do it accurately? So that's why I mentioned earlier on that, yes, you can use a density function to keep track or keep an eye on what the milk fat is. I would say it's not going to be, okay, again, caveat to that. If you have really little or no air bubbles in there, then the milk fat accuracy is going to be quite good. But as soon as you have some micro bubbles in there, that will start affecting the accuracy of the milk fat. So that makes it very difficult to put a let's say an accuracy statement or an accuracy number to that, because you have those micro bubbles that could affect the accuracy of the density measurement.
Okay, great. Two more questions that we can go through. The rest of the questions that we get, we will answer, of course, afterwards. On slide 9, you showed the pump right after the air eliminator. Should it be before to avoid air bubbles produced by the pump?
Well, generally you shouldn't have air bubbles produced by the pump. Unless you have seals or something like that failing inside there. Again, the air eliminator, the primary purpose of the air eliminator is to get rid of larger air slugs. So if you for some reason have if the pump is generating air bubbles, let's say a seal or something like that, and you're drawing air into the pump, that's generally going to result in micro bubbles as well, which again the air eliminator is really not designed to get rid of. So generally you would have the air eliminator before the pump, but I see no reason why you couldn't have it after the pump as well. You know, so for that purpose, it's not super critical.
Then we have a question: what's the inlet-outlet run requirement for Bromas Q?
Zero.
Zero, right? There's no.
Zero. There is no inlet-outlet requirements at all. Not compared to a magnetic flow meter where you need to have, you know, a little bit of inlet outlet, but on Coriolis, none whatsoever. You can put the meter right after the pump. You don't want to put it before the pump, but you can have it right after the pump. You never want to have any flow meter on the suction side of the pump. You always want to have it on the pressure side of the pump. And ideally, I didn't go into those details here. Ideally, any flow meter, don't matter what flow meter it is, magnetic, Coriolis, or any other flow meter, you always want to have it in a vertical position with the flow going up through the meter. That's a general rule for any flow meter. And the purpose of that is that if you have air bubbles, it's going to migrate up through the meter, and also the meter is going to be fully drainable. So if there's any, say when you go to cleaning or emptying it out, it's all fully drainable. So you always want to have a meter vertical and flow going up through the meter.
Good. There are even more questions. I promise you we will follow up on these. We don't have the time anymore as we had 45 minutes today. With this, I want to thank you, Ola, very much for the presentation. I want to thank all participants for their participation. Hope to see you again in one of our next webinars. Just follow us on our online channels, especially on endress.com. Hope to see you again, and I wish you a very great day. Bye-bye.
Thank you so much. Bye.